Clicking to begin. So we've just gone through the thought experiment. What is the arm, or how to push a button in front of you, even though this says what is the arm. It's the same basic question. So let's come out of this, continue recording, and let's write down some of your solutions. If you needed to use your arm to push a button in front of you, what do you need? Somebody. Yes?
You need your circulatory system.
Wow, you went deep. Circulatory system. What's the simplest solution? What's the first thing that's going to touch the button? Your finger. I love it, though. That's a great circulatory question. We're just going to get there. You know, finger. What does the finger need to operate? Yeah?
Joints and nerves.
Yeah, joints. So what make up joints? What are your joints made up of? And the arms. What's the arm got in it? What holds the arm up? Oh, we got muscles. Great, we got bones, right? Because it doesn't do any good to have a finger without a bone in it. It just sort of is a blob of, you're not going to push the button very well, right? Where does the arm start?
Shoulder.
Does it really start at the shoulder? It turns out I have some physical therapist friends. There are muscles that are involved with you moving your arm out in front of you that go all the way down to the back middle of your spine. So it's really hard. And what if you cut off the circulation of your arm? You know, the circulatory system has the heart in the middle of your body, right? So is the heart the part of the arm? It actually sort of is, right? What else do you need?
Your brain.
You need nerves, right? Because you need to get signals, nerves. You need to get signals out to your arm to make the motion happen. Somebody said the brain. Brain's part of the nervous system, right? But it's a very special part of the nervous system. It's where you're going to, create that signal that goes around the nerves. There's one more. It gets a little metaphysical, though, that I'm thinking of. It's really important. Somebody who hasn't answered yet. Thinking, right? You got to have consciousness, which means you got to have software running on the brain, right? Because the brain, outside of a body, right? Brain doesn't really do you any good. The body's not, if it's not working, if the brain isn't working, it doesn't do anything. So you also need consciousness. So you need all parts of the system. You need a structural part. You need an electrical part. You need power. How does power get to your muscles in your body? How does chemical power get to your muscles in your arm? Yeah. From your blood, through the circulatory system, right? So if your battery ain't working, in the robot's case, the battery's like the heart, right? If there ain't any information or any energy going out to the arm, it's not going to work, right? By the way, I grew up on an assembly line, professionally speaking, so when I get excited, I start to use words like ain't, all right? Because that's just what we did. We used that word a lot. Okay, let's come back for a second. So the big point of all of this is, somebody could tell you to make a program to touch the button in front of you. You're going to need to understand all of the subsystems that make that operation possible. So you, as the programmer, are now officially on every team in the robot. You're a hardware guy, you're an electrical guy, you're a programming guy, you're a game theory guy, right? And by the way, in the Midwest, guy is a neuter. It's not a boy or a girl. It's just you guys. Everybody's a guy. Okay? Great. So, having made that realization, that's why we have to talk about the whole robot at the beginning. And some of you are new teams, so you haven't been to a lot of competitions. Some of you have been to a lot of competitions. It's very important to review all of the parts of the system. So when you are working with your robot, you're going to be working with it both at your lab space, which is above this dotted line, and at the competition site, which is below the dotted line. These two are basically mutually exclusive from each other. You don't run the robot the same way in the lab as you do at the competition. You don't run your robot the same way at the competition as you do in your lab. In fact, I believe in the rules, you can't use a wireless from your computer in the pits. So you, by definition, have to connect between your driver station and the thing that's connecting to the joysticks and the robot in a different way. So let's go through all of the things that have to be installed correctly before your robot will work. So this is like thinking about all the subsystems that help you push a button in front of you in your body. We got to think about all the things that are going to be working. First of all, you're going to have a development PC. A development PC is not the driver station little clamshell book that comes in the kit. If you find yourself programming from that little piece of hardware, which replaced a box that was metal, right? You are doing the wrong thing. You must have a PC or a laptop to program with. You just simply must, right? Figure out how to do it. And if somebody says that you can't get one of those things, every time as the programmer you open up the clamshell to program on it, I want you to turn to your mentor and say, gosh, this is a really small screen and this isn't working very quickly. I think that we should be doing something else. Every time you open it, remind them of that, all right? So your development machine is a PC that you've installed LabVIEW and the utility software onto. So there's going to be anything in this that's blue is a piece of software that has to be installed and maintained. You're going to have LabVIEW software on your development machine, and you're going to install the utilities. The utilities, when you install them, will also put three other very important programs on the PC. They are the FRC Creo imaging tool here. They are the dashboard and the driver station software. All right? We'll talk about those more in a bit. When you open up the driver station software, when you open that, you will be asked to put your team number in. So if I were the Chicago Knights, I would put in 1739. In fact, I'm just going to go do that really quickly so that you see this. I'm going to continue recording. Because I just installed the updates and the software on my desktop, there is, whoops, sorry, not on my desktop, under All Programs, and, well, actually, I'm just going to look it up by FRC. Let's see if we can find it. There we go. See FRC? I look it up by FRC, and I find the FRC driver station. The driver station, when you open it, it will ask you if you want to do something, and I say yes. When you open the driver station, it will fill up your front panel or your window. This firewall has blocked some features. It's a good moment to talk about firewalls. We're going to continue to talk about firewalls. They can cause communication problems. In this case, I'm going to allow access for this piece of software. I continue to allow access, and the driver station will then come up in the best way that it can. So I move it around. There are two parts to the driver station. Actually, there are two things that launch with the driver station. There's the FRC driver station's software itself, which is at the bottom. And notice what this says up at the top. FRC PC dashboard, right? So that's the dashboard software. We'll talk a little bit about it now. It's not really necessary for you to use. You've got a place for a camera image over here, and you've got a place over here that tells you what's happening with your drive or how things are operating, and some variables. But we don't need it right now, so I'm gonna make it go away. So on your driver station, there is a place for setting up the driver station. In the driver station, you're going to type in your team number. 1739 is Chicago Knights team number. When I say OK, or when I click somewhere else, notice what happens. You see it 1739 came up here. I believe that that also set the IP address of this machine to be a certain specific IP address. I will come back to the slides now to show you that. Let's make this big. The slides show you that your IP for your driver station is going to be 10. First two letters, first two numbers of your team number. Second, YY is the second two numbers of your team number. Let's see if I can get that back. Here, and then .6 or higher. I think it automatically gives you 6, but if you have multiple people that are going to be developing, you may want to have multiple development machines, and each of those development machines is going to have a specific IP address that's different, unique and different. And the thing that's going to be unique and different about it, you're all on the same team, so XX and YY can't be different. The only thing that can be different is that last number. Every number below 6 is already reserved, okay, for other parts of the system. So what you'll want to do is give a number above 6. If you don't know how to change your IP address, talk to your advisor and figure out how to do it. So if that didn't change your IP address, or if you find something's not communicating in the future and you need to change your IP address, it's a well understood process and there's lots on the internet about it. Once you've got this IP address correct, this is now, and all of this software installed, this is now a driver station and a development station. It's a place where you can write code and where you can test that code by starting up the driver station. The other thing that's going to be communicating with the development PC, you see on the bottom of the development PC I've got a joystick. And I might have 2 joysticks, but I'm doing a really simple robot right now, so I'm just going to use 1 joystick, right? And that joystick is going to be attached at a USB location. Let's go back over to the driver station software. If we look at setup, you'll notice that I don't have any joysticks connected, but under setup you can see where the joysticks are connected to your driver station. If you squeeze the trigger of them, John, can you get a joystick for me? If you squeeze the trigger of them, you can see which one is connected where. It's very important. If you don't have this set up, your robot isn't going to work no matter how good a LabVIEW programmer you are. So when I plug in this joystick, you'll see that it will update. I get the doo-doo. It's installing some driver software. And then I can see which joystick this is. It'll come in over in the joystick setup section of the driver station software. Once it's installing. The nice thing is I have a 4-year-old machine that I'm presenting from, so this will be similar to the performance you get on many of your machines, which may not be the most recent one, especially if you're using a machine from a school district, right? So we're installing the driver software, and that'll come in. You'll see a green over here, and I'll be able to figure out that this is the joystick at USB 1. While that's installing, I also want to show you that there's a section here called Operation. Under Operation, you can set the robot into teleoperated mode, autonomous mode, practice mode, and test. If the robot is not enabled, your robot isn't going to work, no matter how good a LabVIEW programmer you are. So that's why we start here. You've got to think of the robot as both the robot and the driver station together. If you don't have one, the other's not going to work. Okay? So we'll let that continue to come in, and as soon as that says it's ready, we'll talk through what to do next. Also notice over here you've got a section that does diagnostics. So when your robot's connected and communicating, there we go, finally installed correctly. Notice once it installed correctly, on my diagnostics page it says, hey look, you got a joystick at joystick 1. Hey look, you've got joysticks connected. This will also show you if you have communication with the robot. I don't have the robot connected, so we can't do anything there. And I don't have any robot code, which is the code that will go down on the robot. We'll talk about that in a second. Over here under setup, if I come back, if I squeeze the trigger on my joystick, you can see it go blue. So if you ever want to know which joystick is at USB 1, there it is. This is the joystick at USB 1, and I can tell that. Does that make sense to everybody? Great. So I'm going to come back into the presentation now. Here we go. So that's what's happening on your development machine. When you make code on the development machine, that code is going to have to be downloaded over to the robot controller, which is also called a CRIO. If I find out that any of you is calling it a CRIO, I will find you, and in the most graciously professional way possible, I will tell you that it's a CRIO, not a CRIO. It's a compact, reconfigurable I/O. You'll also know it as the robot controller. There's a lot of stuff down in here, including an FPGA. If you don't know what an FPGA is, look it up on the internet later. Okay, FPGA. That FPGA will need to have a correct image on it. The FPGA is basically a chip, and that chip's got to work right. And so the way that that chip works right is by getting an image put onto it. The other thing that's important to know is that this robot controller is a little computer. It's an industrial computer that's made to control things, like a robot or a machine on a factory floor. Okay? What?
Or us.
Or us eventually. Thanks, Mark. We're being taped, you know. Let's try to keep it together. No. So this computer also needs an IP address. The way that that IP address gets set and that the image for the FPGA gets put on the C-RIO is through another piece of software that's over on the development machine. And I want to show it to you right now. We're going to continue recording. On the development machine, there is a C-RIO imaging tool. The C-RIO imaging tool comes in when you've installed the utilities appropriately. So if you haven't gone through the utilities install, it's not there yet. Okay? Or the updates. The way that this thing knows that it's putting an appropriate image onto the C-RIO is that it has been updated appropriately. So if there's a new update, right, and you haven't re-imaged your C-RIO, you still have the old code or the old firmware or the old image down in the C-RIO, and until you actually go through this process, a new image is not down on the C-RIO. So if you're just starting this at the beginning of the season, the first thing you should do is re-image. After you've installed all the software and the appropriate updates, you should re-image the C-RIO. So it's got the right basic information down there. The way this works is it will search for a device. No devices were found because I don't have one connected, but if you find one, it will have an IP address up here and a name. All right? If it's the first time you've done it, that IP address might be 0000. What you will then do is you will put in your team ID. This is the most important thing. That's the number, right? For Chicago Knights, it would be 1739. I would format the controller, hitting the Format Controller button, and I would hit Apply. Now, formatting the controller can take some amount of time, maybe 7 to 10 minutes. If you get something like this to come up, and it says that it can't connect to your controller, and you know you're connected to your controller, then you want to turn the firewall off. You're going to want to do all of the things that you would do to make the connection between the development machine and the C-RIO as simple as possible. You want to take off the firewall. You want to turn off the antivirus software. You want to turn off anything that gets in the way of communication on the internet. Okay? When you go back to using your computer for normal use, you want to turn your firewall back on, by the way, and you want to turn your antivirus back on. Don't not turn it back on. But for this particular activity, if you can't communicate between your development machine and the robot, you want to simplify the system by turning off all of the firewalls. Does that make sense? So you've got to put an image down on the C-RIO, and it's got to be the image that's associated with the current update or the most recent update of the software. That happens through the C-RIO imaging tool, which is on the development PC. When you're actually using your robot, you're probably going to be wirelessly connected between your robot and your development machine. Your development machine has a wireless antenna on it. The C-RIO doesn't have a wireless antenna on it already, though. It does have an Ethernet port, so you can connect through a wire between your Ethernet port and your development PC. That's probably the simplest way to make the connection happen. So if something isn't communicating and you've turned your firewall off and you're using wireless, you might want to turn wireless off and just connect directly with a cable, because guess what? A cable is more reliable than wireless, right? And have 2 cables available to you, because sometimes even cables break. If you're done using the cable and you want to disconnect the development PC from the controller, there's a wireless router in your box, in your kit of parts. It's the white box. Setting up the wireless router takes some time to do, and there are instructions. Guess where they are? usfirst.org, exactly. So go back to usfirst, look at the setting up the wireless router, go through those instructions before you then try to get the development PC to talk to the wireless router. The wireless router will have an Ethernet output. It's actually a switch that can go over to the Ethernet port on the controller. That will allow a communication path between the driver station software and the robot controller. Does that make sense to everybody? If at any point you lose communication, the first thing you should start to do is simplify the system, right? So you might want to take the wireless router out and connect between the CRIO and the development PC directly. If that works, then you know there's something wrong with the wireless router. Go back and reset the wireless router up, right? Etc. Does that make some sense? The only reason I want to bring this stuff up is if you get to the point where you try, somebody says, hey, make the robot run, and you're the programmer, and you give them a program, but the thing isn't communicating, it's not going to work, and they're going to look at you and go, why doesn't your program work? And you're going to go, whoa, wait a second. Let's check that all of the subsystems are working to see if there's something else other than my beautiful code that might be making this not work, okay? So, the other thing that's going to be attached to your router is a camera. Guess where the setup instructions for the camera are? usfirst.org. So you're going to get the setup instructions for the camera and go through them, and I believe out of the box it will tell you how to assign the right IP address, and I think that the image should immediately go on to the, not the driver station, the other thing, the dashboard, the other D piece of software, and it should just work, okay? Some other things to know about. You're going to have a robot that's got motors on it, and those motors are going to be attached to wheels. But we've got to go through the path from the CRIO to those wheels first to make the simplest robot. It turns out you don't have to know any LabVIEW code to get a robot to work, any LabVIEW coding. You don't have to know anything about it to get a robot to work in teleoperated mode. All you have to do is to have set things up correctly. So, your motor needs to get a signal passed to it, and motors usually get a voltage passed to them, and they turn that voltage into motion, right? And I want to see everybody's eyes for this part, because this is important, even though it may be like, what are we talking about? This is boring. This is where the rubber meets the road, okay? So, literally, this is where your robot meets the road, is at the wheel. The wheel's going to attach to the motor. The motor's going to take a voltage and turn it into spinning, right? Where does that voltage come from? The voltage comes from one of many amplifiers, okay? The amplifiers take, let me try to get my cursor back, the amplifiers, eyeballs, put that down, okay? The voltage, physics works, I can see all of you, so I appreciate the ones of you that are paying attention. The voltage is going to come from the battery through the battery management sidecar. Right? There's a big blue thing that's going to deliver voltage to your amplifier. Okay? If that stuff isn't working, your motor isn't going to move. The other thing that comes into your amplifier, and it can be a Jag, a Victor, or a Talon? Yeah. Talon, that's what it's called, right? Right? Is going to turn that voltage into a certain amount of voltage that goes into the motor based on a control signal. The control signal comes from a PWM pin on a thing called the digital breakout sidecar. All right, the digital sidecar, the digital breakout board, has some pins on it called PWM pins. Do you know what PWM means? Pulse width modulation. So you're going to have something that's true or false because it's digital, on or off. It's going to be on for a certain amount of time, which gives you the width, and that amount of time is going to change. That's the pulse width modulation. Does that make sense? Okay. The pulse width modulation is going to be set up by the code, which is in the CRIO, and the thing that connects the CRIO to the digital sidecar is a big gray cable and a thing called a digital module. The digital module is probably the 9401. Okay, so you'll be able to read 9401 on it. When you connect the big gray cable from it to the breakout box, that's when a signal can go from your code out through the PWM signal, through an amplifier to your motor, and the motor can move. If any part of that system hasn't worked or isn't set up right, you're going to give code to your team, and it's not going to work, and they're going to look at you and go, why does your code not work? And you're going to say, wait a second, let's take a step back and make sure all the subsystems are working. And you're going to travel either backwards from the motor to the digital module or forwards from the digital module to the motor, checking all of your cables. Does that make sense to everybody? Everybody good? Great. Most of you, if you're a newer team, will want to start with a simple drive train, which usually includes having two motors, one on each side of the robot, And there are two ways that that can work. In arcade mode, where you get one joystick, you move it in the Y direction and in the X direction, and the code is going to figure out how your X and Y together get turned into power to the left and right wheels. That's the easiest robot to make, and if you make that mechanical robot and you download code, which is what we're going to talk through the process of doing that next, and everything works, then you know that every part of your system is working, and then you can go and make a more complicated robot, right? So a really nice thing to do at the beginning is to make just a simple arcade drive robot and have it ready for you, because you don't need to know any LabVIEW code to make an arcade drive robot work in teleoperated mode at the beginning. That make sense to everybody? Okay. That's how you're going to talk to the robot in your lab. There's a difference when you get to competition. In competition, you're going to walk up to a big plexiglass area on the field, and that plexiglass area is going to have a bunch of Ethernet cables. The Ethernet cables are going to connect directly to your drive station, your driver station. The driver station technically is the little computer, the little clamshell that came in your kit of parts. That is not your development machine. Can you use your development machine as your driver station at competition? The answer is yes. So if you want to use your development machine as your driver station, you can. But if anything that you did to modify your driver station makes the driver station not talk to the field management system, what they're going to do is they're going to move you right back to the clamshell. So it might be a good idea to make sure that your code always works with a clamshell running just the driver station unmodified. Does that make sense? The dashboard can be modified. Some modifications in the past have made things not communicate. If your development machine does not talk to the field management system, then the first thing they're going to do so that they don't slow the competition down is take you back to the driver station. The driver station also has to have software put on it, right? The driver station has to have software put on it. It's the exact same software that you get for the development machine. The difference is you don't have to put LabVIEW onto it. You've got to have the driver station software, the dashboard software, and the utilities. What you don't need is the Creo imaging tool, and you don't need the LabVIEW for FRC. Okay, great. The driver station will also have a USB set of ports that you can hook your joystick to. Okay? The joystick, when you hook it into the driver station, if you hook the joysticks in the wrong order, they can end up being out of order. So joystick 1 is joystick 2 and joystick 2 is joystick 1. It happens to figure, basically it's the order in which you plug them in, and if you're not being careful and plug them in a different order, they might go in the wrong way. You can go back into the driver station software, figure out which one is which, and in the driver station software, if I continue recording, in this driver station software, you can actually move this from one place to another on the setup page. So you can make whichever joystick, whichever USB port you want. Okay? It's a very common problem, so I bring it up. The field management system then has a superset of wireless antennas in it, and those wireless antennas are going to talk to the mobile robot. You cannot turn your wireless on in the pits at competition. So my suggestion to all teams is that you have a very long Ethernet cable, and probably 2 of them, with you at competition. Why is that? Because robots move, and if you have a very short Ethernet cable and you've got your very expensive laptop connected to your very expensive robot, right, and they separate from each other in a violent way, you can rip your Ethernet port out of your laptop or out of your Creo, and those are expensive to fix. So I would say a 20-foot cable is key to having at competition with you, because you can't use wireless. All right? The only thing that we haven't talked about so far is getting code from the development machine onto... Oh, by the way, before we talk about getting code from the development machine onto the robot, are there any questions about the hardware setup? Either at competition or in your lab? that either means that I was incredibly good at this, or none of you understood a thing that I was saying and don't know what to ask, and that's perfectly fine with me. Okay? Yes, question. Okay, so the question is, how do you connect the computer to the wireless router? So, if you take a look up here, the computer, meaning the development machine in this case, right, has a wireless in it, right? So if it's got the correct IP address, and you've programmed your router to have a correct IP address, notice it's 10.team number, and then 1.1. If you set that up correctly, then your computer should be able to see that wireless router as an option. You should be able to ping it. If you don't know about pinging, look it up on the web. You can type on the command window, you can ping from this computer to 10.this.this.1. As soon as you can ping back and forth, that means they're talking to each other. And if this is then directly connected through an Ethernet cable to port 1 of the C-RIO, the robot controller, then that communication path will work. So that's how you connect the computer to the router. It's simply a case of setting up the IP address correctly. There's another comment. Yes?
In the tutorials.
In the tutorials.
LabVIEW, you go to
yes.
Open the LabVIEW in the tutorials.
Yes.
It explains how to connect your C-RIO to your computer.
Okay.
It also shows you how to set up the router.
Great. So there, we've also put some of those tutorials into our software, which is good to know. But again, my basic idea is go back to usfirst.org, because if we said anything wrong and it conflicts with what's in usfirst.org, they're right. Okay? Great question, though. Any other questions about the hardware setup in your lab or at the competition? Okay, great. So I'm going to stop recording.